Let's learn how to find the inverse Laplace transform using a step-by-step process. So if you get a expression like that, and you can see that there are distinct linear factors in the denominator. So if we have distinct linear factors, we have a kind of quick way to get the answer. So everything starts with writing the partial fraction decomposition. So we can write the partial fractions because we have three distinct linear factors. So we can write the partial fraction as this is identical to like three lines. We write this one as a over s minus 1 plus b over s minus 2 plus c over s minus 3. I know that sometimes some people write this one as like this equal to. That is not actually correct because we can use the properties of identity. So if you write just equal sign, you cannot use properties of identity and your argument is actually incorrect. So make sure you write like three lines here just to make sure that this identity. So we use the properties of identity. So the both sides are exactly equal. That's identity means. Good. So after that, what's the question is how to find this A, B, C. So now the question is finding A, B, C. So we can use what they call the cover-up method for that. So what is the cover-up method? So what we're going to do when you use the cover-up method, you actually just use a simple substitution argument, but ignore this factor in the denominator. So that means we can cover up that factor. So that means we can write something like this. For example, if you want to find A, so what we can do, so we're going to cover up that factor. That means we're going to cover up this factor. So that means we can remove that and we can write the rest. So that means it is going to be 3x squared plus s plus 7 from the numerator. From the denominator, you remove s minus 1 factor, so you only have s minus 2 and s minus 3. So that's the cover. And then you just substitute the 0. So you can see we have s minus 3. So that means 0 is 1. So you can plug in s equal 1 to this expression, and this is going to give you the value of a. So if you plug in 1, and you can see that you get 3 plus 1 plus 7. And in the denominator, you can see when you plug in 1, you get negative 1 times negative 2. So when you simplify, and you can see that you're going to get 11 over 2. So that is the value of A. And similarly, you can find B and C like this. So we remove the s minus 2 factor and plug in s equal to. Remove this minus 2, plug in s equal to. So if you do that, you get this. So you get negative 21. And for C, you get 37 over 2. Now since we have all the values, now we can just plug in back those values back into the partial fraction and find the inverse Laplace transform like this. So next what we can do is, we know that the inverse Laplace transform is linear. It's a linear property. So because the linear property, what we can do, we can break this down to three different parts like this. So you get three different pieces now because the linearity, and also you can see that you can take the numbers outside of that again by the linearity property because the linearity says that. So that means if you have like a sum or a difference, you can break it down to 2, and also if there's a constant, you can pull the constant out. So that's the linear property. So that's exactly what we use here. So now what we're going to do, we need to invert all of those terms. So for that we use one of the special result that we have, and we know this like what we normally call the eat function property. So that means if you have a Laplace transform of the e to the at function or the eat function, what happens is it is simply going to be 1 over s minus a. That's the one. So because of that, if you go with the inverse, and you can say if you get the inverse of the 1 over s minus a, so this is going to be e to the at. Remember the opposite sign. That's how we remember this one. It's always the opposite sign. That's the easier to remember this one because it can even be plus. So because of that, now we can invert them. So that means the first one is simply going to be 11 over 2. So here we have 1 over s minus 1. We have 1 over s minus 1. So in this case, 1 is the a. So that means it is going to be e to the 1t. That means e to the t. Next one is going to be 21 e to the, in this case a is 2, so it is 2t. And the third one going to be, you can say 37 over 2. So that means it is going to be e to the 3t. So that is the inverse Laplace transform of that. Now try these two problems as practice problems. So the first one has 3 linear factors. The next one, actually the factors are hidden. First you need to factor them out using difference of squares, and also don't forget the first one, whichever s equals 0. So we can use here the property that a squared minus b squared equal a minus b and a plus b as factors. So you can try these two problems now.